Welcome back, everybody. We're about to take a deep dive into a study about how dogs experience cold
Sounds intriguing.
and what it might reveal about pain in our four-legged friends.
Looking forward to it.
The study is titled, Awareness of Chronic Pain in Animals Has Increased,
Okay.
and it delves into a potential new method for assessing pain in dogs.
Fascinating.
So today we'll be exploring why researchers are interested in cold sensitivity,
All right.
the challenges they face in this research,
Yeah.
and how this all might impact how we care for dogs in the future.
Yeah, that's a big one.
To start us off, can you give us some background on why understanding chronic pain in animals,
Sure.
and specifically in dogs, is becoming so important these days?
Well, there's been a significant shift in how people view their pets.
Yeah.
They're really considered family members now more than ever.
Absolutely.
And that naturally brings a greater focus on their overall well-being,
Makes sense.
including protecting them from pain.
Right.
So this growing awareness, especially regarding chronic pain in dogs,
is a major driver behind a lot of research in this area.
For sure. The study you shared mentions quantitative sensory testing, or QST.
Right.
I'm not familiar with that term. What is it exactly?
QST is essentially a way to measure someone's sensitivity to different sensations.
Okay.
You can think of it as a tool to look into the nervous system
Interesting.
and spot subtle changes that we might not easily see from the outside.
Got it.
In humans, it's often used to diagnose and monitor conditions that affect sensation, particularly chronic pain.
So QST helps uncover hidden sensory issues that might be linked to pain.
Exactly.
So what kind of tests are included in a QST battery for humans?
It typically involves a range of tests that assess different aspects of sensation,
Okay.
like, for instance, thermal thresholds, which measure how sensitive someone is to cold, warmth, and even pain from heat.
Got it.
There are also mechanical thresholds, assessing sensitivity to touch, pressure, and vibration.
Makes sense.
And naturally, there are tests specifically designed to gauge pain sensitivity, like the pinprick test.
Interesting. So are there similar tests for dogs?
That's the burning question. While we have QST protocols for dogs,
Right.
mainly focusing on mechanical and heat thresholds,
Okay.
using cold stimulation to assess their pain is still a fairly new area of research.
I see. So this study's focus on cold stimulation is what makes it so intriguing.
Exactly. The key here is the link between sensitivity to cold and nerve injury.
Okay.
Increased sensitivity to cold, or what we call cold hyperalgesia,
I see.
is often a sign of neuropathic pain, which stems from damage to the nervous system itself.
Oh, interesting.
Research has shown that this cold hyperalgesia is present in both rats and humans with nerve injuries, and even in conditions like fibromyalgia.
So cold sensitivity could be a window into understanding nerve-related pain in dogs.
Exactly.
How is cold stimulation actually carried out in research?
There are several methods for human studies.
Okay.
We often use what are called latency measurements, where we apply something cold and measure how long it takes for the person to react. Another approach is something called ramp-down cooling,
Okay.
where we gradually decrease the temperature until the person indicates they feel it.
Interesting. This study used a specific device, right?
Yes, they use the Semitic MSA thermal stimulator,
Yeah.
which is frequently used in human research, but it hasn't been studied extensively in dogs, making the study quite unique.
So this study is a sort of trial run to see if this device can be used for pain assessment in dogs.
Precisely.
So to recap, they were trying to figure out if this device works well for cold stimulation in dogs,
Yes.
how dogs react to different cooling rates,
Right.
and if it could eventually become a practical tool for vets to use when diagnosing pain.
You got it.
Going into this, the researchers had a specific hypothesis, didn't they?
They did. They hypothesized that faster cooling rates would cause a stronger reaction in the dogs.
Interesting. So faster cooling equals more noticeable response.
That was the idea based on human studies, where faster cooling usually leads to stronger cold sensations.
That makes sense. So did their findings back up this hypothesis?
Well, surprisingly, no. Their results didn't quite match their initial prediction.
Really?
Faster cooling rates didn't actually lead to more reactions from the dogs.
That's interesting.
In fact, the overall response rate to cold stimulation was pretty low.
How low are we talking?
Only about 12% when we combine the data from all the cooling rate protocols.
That's pretty low. So the dogs weren't really bothered by the cold stimulation.
It seems that way at first glance.
Interesting. What else did they find out about how dogs react to cold?
One key finding was the impact of the experiment day.
Okay,
There was a noticeable difference in response rates across the 3 days of the experiment.
I see.
They saw more reactions on the first day compared to the second and third.
So the dog's responses to the cold changed over time.
Yeah, which raises some intriguing questions. It makes you wonder if maybe they got used to it over time.
You mean like they habituated to the cold stimulation?
Exactly. That's definitely one possible explanation.
That makes sense. Speaking of the study's design,
Yeah.
the article mentioned that they used beagles. Can you tell us a little more about that choice?
Sure. Beagles are often used in research for a couple of reasons.
Okay.
First, they're generally known for being pretty docile and easy to handle,
Right.
which makes them well suited for studies like this.
I can see that.
And second, using a single breed, especially one that's commonly used in research, helps minimize variability in the results.
So they're like a standard model for research.
You could say that.
And, of course, we have to ask about the ethics.
Absolutely.
Were there any ethical considerations with using dogs for this type of research?
Of course, ethical considerations are always paramount in animal research.
Right.
This study protocol went through a strict ethical review process
That's good to hear.
and received approval from the appropriate authorities.
Okay.
Throughout the study, the researchers followed strict guidelines to ensure the well-being of all the dogs involved.
That's reassuring. So can you walk us through the specifics of how the experiment was set up?
This was a prospective experimental study with a randomized, partially blinded design.
Okay.
10 healthy beagles from the university's own colony
Got it.
were divided into subgroups for the experiment,
I see.
and they tested those 4 cooling protocols we talked about
Right.
on 4 different body regions of each dog.
And what were those regions exactly?
The neck, the lumbosacral area, which is basically the lower back,
Okay.
the elbow, and the knee.
Interesting choices.
Yeah.
Why those specific areas?
Well, those spots represent different parts of the body with varying skin thickness and nerve distributions.
So by choosing these different areas, they can see if the location of the cold stimulation affected the dog's reaction.
Exactly.
Makes sense.
Yeah.
And did they repeat these measurements over time?
Yes. The experiment was conducted 3 times per dog,
Okay.
with a 1-week gap between the first 2 sessions and a 3-week gap between the second and third.
So they spaced it out a bit.
Yeah. This approach let them evaluate the repeatability of the method and consider those potential habituation effects.
Right, which seemed to be happening.
Exactly.
So what specific reactions were they looking for from the dogs during this cold stimulation?
The study defined avoidance reactions as any of the following:
Okay.
withdrawing from the thermode, vocalizing, like yelping or whining,
Got it.
startling, or even turning their head towards the thermode.
So any sign that the dog was trying to avoid the cold?
Pretty much. And they also looked at the feasibility of each measurement.
Meaning how easy it was to actually do the test.
Exactly. They used a scoring system for that.
Can you tell us more about that scoring system?
They used a scale from 0 to 5,
Okay.
with 0 indicating excellent cooperation, meaning the dog stayed calm and didn't need any restraint.
And what did a score of 5 mean?
A 5 meant they couldn't do the measurement properly.
Oh, I see.
Maybe the dog was restless that day, or something startled them during the test.
That makes sense.
Scores above 1 were considered not ideal for reliability.
Okay.
But thankfully, 95% of the measurements received a score of 0 or 1.
So most of the time, the dogs cooperated well and the method was easy to perform.
Exactly. Which is a good sign for its potential use in a clinical setting.
Definitely.
Yeah.
If the dogs had been fighting the researchers, or if the procedure had been super complicated,
Right.
it wouldn't be practical to use regularly in a vet practice.
You got it.
Let's dive into the results now. The article mentions they did some statistical analysis.
Right.
Can you break that down for us? What kind of statistical methods did they use?
They used a mixed logistic model to analyze the data.
And why did they choose that specific type of model?
Well, it's particularly useful for analyzing data with multiple measurements per subject.
Which is what they had in this study, right?
Exactly. Each dog was tested 3 times.
Right.
So this model helps account for the fact that those measurements aren't independent of each other.
Makes sense. So the model helped them factor in the repeated measurements from the same dogs.
That's right. It also allowed them to assess the influence of different factors,
Okay.
like the cooling rate, the day of the experiment, and the location of the stimulation.
Right, to see which of those factors actually affected whether or not the dog reacted.
Exactly.
And did any of those factors turn out to be statistically significant?
Interestingly, yes.
Okay.
While the cooling rate itself didn't significantly affect the response rate, Both the location of the stimulation and the day of the experiment did have a significant impact.
So the speed of the cooling doesn't matter much.
It seems that way.
But where they applied the cold and which day it was did make a difference.
Exactly.
We already talked about habituation.
Yeah.
So the significance of the experiment day isn't too surprising.
Makes sense.
But tell me more about the location. How did that play into the results?
Well, the dogs were significantly more likely to react when the cold was applied to their elbow or knee
Interesting.
compared to their neck or lower back.
So certain areas were more sensitive than others?
It seems so.
Why do you think there was that difference in sensitivity based on location?
Likely a few factors at play. The skin on the elbows and knees tends to be thinner than in other areas. And those areas also have a higher density of sensory receptors.
Oh, interesting.
So basically, the nerves are closer to the surface in those spots,
Got it.
potentially making them more sensitive to temperature changes.
So even though the study didn't find a direct connection between cooling rate and response,
Right.
the fact that location was so important suggests that cold sensitivity could still be a good indicator of pain,
I agree.
especially if we focus on those more sensitive areas.
That's a great point.
It seems like further refining the methods,
Yeah.
maybe by zeroing in on specific locations or using different temperature ranges, could make cold stimulation even more effective for pain assessment in dogs.
Definitely worth exploring further.
And it's crucial to remember that this study was done on healthy dogs. It's quite possible that dogs who are actually experiencing pain, especially neuropathic pain, would react much more strongly to cold.
Yeah, that makes a lot of sense. This study is really just a first step
It is.
in exploring the potential of cold stimulation for pain assessment.
Exactly. The logical next step is to see how these findings translate to dogs with different kinds of pain.
Absolutely. The paper does mention some limitations of the study.
Yes, of course.
Do you think any of those limitations could have really skewed the results?
Like with any good research, the authors acknowledge the limitations of their study,
Right.
and some of those could have potentially influenced the findings.
Okay.
For instance, the fact that the researchers held the thermode against the dog's skin by hand
Yeah,
could have introduced some inconsistencies in the pressure applied,
I see.
which might have affected how the nerves were stimulated.
That makes sense. It would be tough to maintain perfectly consistent pressure when you're dealing with a live animal.
Exactly.
Yeah,
Even a calm beagle.
right. And on that note,
The dogs in this study were used to being handled by researchers,
yeah, so they might have been less likely to react to the cold.
compared to, say, a typical pet dog who isn't used to that kind of interaction.
Right, so their experience as research subjects could have potentially skewed the results towards lower reactivity.
Interesting. The authors also mentioned that using only beagles from a limited number of litters might limit how much we can generalize these findings to other breeds. Sure, but I imagine using a more diverse group of dogs would have made the study much more complex.
Definitely. And the fact that they used a relatively homogeneous group allowed them to use a smaller sample size.
Right, which is always a good thing, ethically speaking.
Exactly.
So while we have to keep these limitations in mind,
Of course.
this study still gives us some valuable insights into the potential of cold stimulation as a way to assess pain in dogs.
Absolutely. It's an area that definitely deserves more research.
I agree. It seems like there's a lot more to uncover here.
There is. The findings from this study lay a strong foundation for future research.
Yeah. That can delve deeper into this promising avenue of pain assessment in our canine companions.
It feels like this research is really opening up a whole new way of thinking about pain in dogs.
It is. It highlights how important it is to keep looking for new and better ways to assess and treat pain in animals.
For sure. We owe it to our furry friends to give them the best care we can.
Absolutely.
And that definitely includes recognizing and alleviating their pain.
Couldn't agree more.
You know, I'm curious about the device itself.
Oh, the somatic MSA.
Yeah. What are the pros and cons of using that particular device for this kind of research?
Well, the somatic MSA is a well-established tool in human research.
Right.
And it has some clear advantages when studying cold sensitivity.
Like what?
One big plus is its precision. It delivers those temperature changes in a very controlled way,
Oh, okay.
allowing researchers to test very specific cooling rates.
So it takes out the guesswork when applying the cold stimulus.
Exactly. And it's computer controlled,
Uh-huh.
so you can program different cooling protocols,
And keep things consistent across measurements.
which is essential for getting reliable data.
Right. It also has a fairly large contact surface.
Okay.
Which is helpful for stimulating a wider area of skin.
So it sounds like a pretty good tool. Are there any downsides to using it with dogs?
One potential limitation is that the thermode has to be held in place manually.
Right. We talked about that earlier.
Yeah. And that manual application could introduce some variation in pressure, which might affect the results. Ideally, we'd have a device that could attach to the dog's skin securely without needing that constant hand pressure. But that technology doesn't exist yet.
Yeah. I can imagine designing a device like that would be pretty tough.
It would be, especially given how much dogs like to move around.
For sure. Another thing to consider is that this device was designed mainly for human research.
Right.
It seems to work fine in dogs. But there might be more suitable tools out there, specifically made for veterinary use.
So there's always room for improvement. There is. But it's encouraging to see that we can adapt tools from human research for use in animals.
It is. This study definitely has me thinking about the future of pain management in dogs.
Yeah, me too.
What are some of the main takeaways from this research?
Well, I think one of the biggest takeaways is that we still have a lot to learn about how dogs experience and express pain.
Okay.
This study looked at cold sensitivity, but it's just one piece of the puzzle.
Right. There are lots of other avenues to explore when it comes to pain in dogs.
Absolutely.
What areas of research do you think hold the most promise for really moving the needle?
One area I find particularly exciting is the development of objective pain scales for dogs.
Oh, interesting.
You see, these scales are all about moving beyond those subjective assessments.
You mean like those based on behavior?
Exactly.
Yeah.
And instead providing more quantifiable measures of pain.
I see.
So this could involve things like physiological markers.
Like what?
Heart rate variability or cortisol levels.
Okay.
Or even advanced imaging techniques. That let us actually visualize pain pathways in the brain.
So basically taking a more data-driven approach to pain assessment.
Exactly.
It sounds like there's a lot of groundbreaking research on the horizon.
There is. And as we continue to deepen our understanding of pain in dogs, we'll be better equipped to give them the care they need.
And ensure they live those happy, pain-free lives we all want for them.
Absolutely.
Well, I think it's time to wrap up our deep dive into this fascinating study. Thanks for sharing your expertise with us.
My pleasure. I always enjoy chatting about new discoveries in animal health and well-being.
And to our listeners, we hope this deep dive has given you some new insights into the complexities of pain in dogs.
Yeah.
And the amazing work being done to improve their lives. From vet, neurojar.
Keep those minds inspired and tails wagging.